Alright, in this video I want to demonstrate how to create dendritic structures in Blender using particle systems and the minimum spanning tree add-on. The add-on uses a technique for creating tree structures published by Hermann Kunz in his Trees toolbox. It's a modified algorithm of the minimum spanning tree with an added balancing factor. The difference between balancing factors is how the distance from every point to a root point is weighted. This is important for realistic dendritic structures, as we have to take the cost of the whole structure into consideration, as well as the distance to a root. As an example, we'll try to create a structure like this from Hermann Kunz's research paper. Now for the point distribution, we'll use a weighted particle system like this one. I've painted the rough shape of the particles using weight paint and then used the vertex group as density. Now to create a spanning tree, you have to choose the object in the minimum spanning tree panel, and we'll choose curve for now as a build type, and then we can just click create MST and there is our tree. For now it's just two-dimensional though. Now to make this tree three-dimensional, the add-on can spin the points along an axis of the object. If we activate this, the add-on now creates a 3D tree based on the 2D point distribution, as you can see here. And now, as you can see, the example tree branches in the middle section, while our tree only branches pretty late. So that means that our balancing factor might be off. The high balancing factor causes more branches directly to the root of the tree, while a low balancing factor avoids multiple parallel branches. So if we choose a balancing factor of 6, for example, our tree now branches a lot earlier, and it even looks like we have all the 3 branches like in the example. Next we'll try to add thickness to the dendrite. For that we just need to tick the add thickness box, and I've chosen a few settings already here. So if we create this, we now have a dendrite with added thickness. Now offset and scale you can play around with, but the important option is the path scale. Since the radius is gathered by research data, we have to scale it down to a realistic size. Our dendrite model is about 6 Blender units long, or maybe 7. And so if we multiply it with the path scale, we have about 700 micrometers size. So as long as you stay within, say, 10 Blender units, you should be fine with a path scale of 100. Last thing I want to show you is how to create dendritic trees for multiple neurons at once. For that we just need another layer with a particle system. Of course you can use the vertex paint density again if you want to. Now just choose the object in the particle system in the dendrites panel down here and click create dendrites. Now this takes some time, as it's creating a unique tree for every particle on the plane. The settings of the dendrites are the ones from the MST panel up here. Trees are also rotated to fit the normal of the face, so the z-axis of the dendrite is always perpendicular to the plane, as you can see here. So, this is how you create realistic dendritic structures in Blender. Be sure to check out Hermann Kunz's research paper on the algorithm in the description, and check out the add-on on GitHub. Thanks for watching.